Good evening, and welcome to this project walkthrough with the Hacker Collective. And here we have Ben, we have Chanhon, and we have Jeffrey with us. They're architects actually, and you guys might think, what does this have to do with the Hacker Collective? So the thing is, they are actually very passionate about this thing called parametric design, and this thing isn't something that's very commonly heard in Malaysia right now. Am I right? Or even in Southeast Asia, am I right?
Yes. It's actually not really exposed in considered in Malaysia yet.
Right. So that's why they want to be the ones bringing this art in. So but first let me briefly go through about the Hacker Collective. So basically, the Hacker Collective is like a community with the vision where we try to encourage this self-taught movement to Southeast Asia and possibly even larger in Southeast Asia. And we want to encourage more developers into the industry to fulfill range of classes from web development, data science, and mobile app development. If you guys are curious, you can learn more about us at thehackercollective.co, and we're also on Facebook, Instagram, and LinkedIn on the Hacker Collective. So right now, let's begin. Ben, Jeffrey, and Chanhon, tell us more about yourself. Like, what do you do? How many years have you been an architect? And what are you up to currently?
Okay, so based on my last 2 weeks, I actually introduced myself, but I'll briefly introduce again.
Yeah, just briefly introduce you.
Yep. So I'm actually a master architecture student from Germany. So at first I did my architecture in Taylor's, Malaysia. Then after that, I pursue my master's in Germany. Then from there, I'm exposed more to parametric architecture. Then after a few years of training there, then somehow I wanted to bring the knowledge back to Malaysia and share it with the others. And I'll pass the next introduction to Ben.
Yep, so for me, I'm Ben. All of us were studying architecture in Taylor's at the same time, so we all graduated from there. But in the case of me and Jeff, we went to RMIT in Australia instead, and we studied
Masters in Design, Innovation, and Technology.
Yeah. So from there on, we learned a lot about digital fabrication and parametric design, and we just sort of formed a passion for it. And so when we came back, we found that it's not really being practiced here, but we really would like to build an awareness and a community around it, which is something we hope to achieve. Yeah, so that's good.
Right, nice. So what about now for right now? So what are you guys up to? Are you guys an architect, or are you guys maybe like industrial designers? Or
At the moment, I'm working in steel fabrication. So after my work in Australia in architecture, so I moved back in Malaysia and kind of want to learn more of the fabrication limitation in Malaysia first.
Nice, I see.
For me, I'm actually doing more on like architecture based projects. Then on my free time, I'm trying to build up my parametric career. And after Ben came back, so we thought of like collaborating together, try to build this as a platform for all others.
Yeah. So when I was in Melbourne, I was working with artists doing public art and 3D modeling for them. But when I came back to Malaysia, right now I have some smaller projects on the side, more to do with like 3D printing and of the sorts. And yeah, that's pretty much what I'm doing right now.
I see. So let's get into this topic of today's event. So what is parametric design?
Okay, should we show slides?
Yeah, sure.
Yeah, we will share our slides to easily explain what's parametric design.
Okay.
Yeah, so share this. Okay, sorry.
Yeah.
Share.
Yeah, share.
Screen.
Share. Yeah. Okay.
All right, and then we look at this. Go to the top. Don't forget. Full screen. Can you see the screen?
Hold up, guys. Hold up. It ended really somehow.
No.
Hold on. Sorry for this another technical error. Yeah. Back to where we stopped just now. Right. So right now, Ben, Chanhan, and Jeff. So
Sorry.
guys, you are.
Yeah, we will start.
Yeah.
So, yeah.
Okay.
So basically, parametric design is, I mean, the name itself explains it, like it's parameters in a design. So it's more like a way of thinking or kind of a design logic. So people use parametric design is one of different ways to do their design kind of work. So to easily explains it. So when it comes to parametric design, you normally have data parameters criteria that we put into using softwares that we use to help us achieve the kind of outcomes to do analyzing, visualizing, or fabrication to get our end product, which our concept design, design development, and construction or construction documentation. So to explain it even further, I'll show you through so this is the tools that we use to do parametric design. So this is a software called Rhino and Grasshopper. It's kind of like the visual programming. So to explain parametric design, simple is you have your parameter and you have your set of rules. So our set of rules here is these few components. So what this component do is it extrude. So this is an extrusion thing. So that is a parameter. You want it to extrude 200, and our parameter will be our rectangle and our shape of it. So that's how parametric design is. You control the parameters and you provide a set of system, or like in coding where you have a specific function. So when you change your base geometry to like different kind of shape, you can actually easily change it. So now you have one single parameter. You get all more parameters into your set of rules or your function. Now you can change like two kinds of different parameters to get your different kind of an end product. So that generally explains parametric design in a very simple term.
So for someone who is not from an architectural background like me,
Yep.
Would you say that parametric design is just using numbers and data to convert it into drawings?
In a way, yes.
In a way, yes, but of course, when you are using this on a more architectural platform, then there are more design terms and rules and parameters coming in. But in a very simple way, yeah, you're right. Data and parameters will decide what the design outcome would be.
Yeah.
So it's a hybrid of technical side, which is the engineering and stuff, also the creativity all combined. So it's like both worlds in one single platform.
Right, I see. So now that we sort of like have a brief understanding of what parametric design is, so can you give us some architectural examples of what parametric design is? Like, you know, what buildings they...
Yeah, sure.
Yeah, sure.
I'll give you an old example.
So this is a very traditional, the very old ways of like parametric is. This is an Antonio Gaudi's work, which is the Sagrada Familia.
Yeah, so usually you think about parametric design is just within the realm of computers and everything, right? But this is how they did it back then. This is also parametric design in the way that he used the weights to pull down the strings to develop the shape of the curve, that which, and then he used a mirror to reflect the shape of the form that was made by those strings and the weights. And this would later form the building, which is Sagrada Familia. So this is like a very old kind of parametric design. And yeah, nowadays we use numbers and data to simulate what's happening here, because they're all math, all curves and shapes. Those are all numbers, right? Those are math. So basically we're just controlling math shapes, which is pretty interesting to see it being done in the olden days. This guy's a genius.
It looks very complicated.
Yeah, so generally you won't even come up with these kind of designs with the
Yep.
regular method, right? But you
Yep.
can see that it's very organic, but it's not like it's not just out of like someone's creativity, but it's actually out
Yep.
of real calculations and all that. So the shapes are properly designed and really well thought out. Yeah. And I guess that would be an old example, like, but for modern examples, this is a famous architect, I guess, or architecture company. Zaha Hadid is a very, the late Zaha Hadid. She's a very well-known architect, and you can see her buildings have these very wild shapes to them and very organic curves to them, and that's all math as well. You know, she's well known for doing these kind of designs and generating these kind of shapes within with parametric design is very simple, very easy, and yeah. So those are pretty simple examples of what you see nowadays in relation to parametric design. Of course, there are smaller scale things as well, like interior architectures, how shops look inside, or like sculptural objects. You can find those being made by parametric design as well.
I see. Like I did a brief Google search on Zaha Hadid, and apparently her firm was the one that designed the Beijing Daxing Airport too, right?
Yes,
Was it?
correct.
So so in this sense, parametric design doesn't have to be something that's overly complicated, but something that's just not your regular rectangular buildings. Am I right?
Yes.
Yes, you're
That's right. That's right. A lot of people
see.
like have this misconception that parametric design makes crazy shapes and they're all very
Right.
complex, but they're not actually. Like you can make something really simple with parametric design, but the thing is there's more depth to the design.
Right.
There's more things that you can resolve within the code or the program.
Yeah, because what I feel is parametric, it actually looks very fresh to the eyes because you know, as compared to all the square and rectangular buildings, right?
Yeah.
Right. So how about this? So for starters, for beginners who are, you know, for those young kids, they are just driving in the streets thinking, oh, this building is so awesome, I want to design it someday. How can they venture into parametric designing? How can they be the ones designing all these models, these buildings in the future? How do you venture into it?
It's quite complicated in this sense because firstly, of course, you definitely need a basic of like
Design.
an architecture practice first.
Or you need a team.
Yes, you need a team.
So, but for beginners, they want to venture into it, they can simply actually in Google or the Grasshopper forum, they are quite welcoming and helpful.
Yeah.
So when they start, they can actually learn a lot of stuff. It's like coding. There's a lot of things you search in Google. You can learn from a lot of tutorials. Just that what kind of specific stuff you want to do, then that's a bit hard for you. Which one you want to search on and all.
Yes.
So because Grasshopper, the way you learn this Grasshopper stuff or this parametric stuff is a linear curve kind of learning process. You always keep on learning. It depends on what kind of outcome you want, then you search for it. If it doesn't know how to do it, so
it's quite similar to coding, I would say, right? So you just like, you know, keep testing, debugging and stuff like that. And you know, from there, from mistakes you learn and keep learning and keep evolving your practice, I would say.
I see. And let's jump back to what you demonstrated. What was that software that you used to render your models?
So on the left side, that's Rhinoceros 3D. This is the 3D modeling software that we regularly use. It's a normal 3D software, but it has a plugin called Grasshopper. Grasshopper is what we use to do parametric design. It's basically a visual programming platform for parametric design. And it has lots of these components within it that help us create what we want to create. Like, for example, see this, it says rectangle, right? So the use is just to create a rectangle on a plane, and we feed it the data that it needs to create that rectangle. That's why we can change the data that we give them to edit the object that's being generated.
So what's good about this software, it kind of allow creative or designers to bridge into the coding world without doing the coding, because
Yeah.
you want to do a rectangle and you type with this code, it's a bit hard for us to do it, but
Right,
they
right.
generally
Yeah.
already created this kind of component that easily allows us to get the kind of outcome we want, the visual outcome we want, and we just plug and play.
Yeah.
I see.
And if you were savvy enough in coding, you could actually create your own
Yeah.
components, because they
I
do
see.
allow that kind of stuff to happen.
I see.
So for example, there's the, where is it?
They do allow like
Yeah, scripting.
you can create your own
C#.
C# scripts or your
Python.
Oh,
Yeah.
So that's kind of, you create your own kind of special component to do different
Special
outcome or
things.
output.
right. So it's like different libraries in coding sense.
Yeah.
Yes, correct.
I
That's
see.
correct.
I see.
This is more
So,
of a platform, a general platform for every script to be on.
Yeah. And it's sort of like open source. So you get so many plugins that you can insert into Grasshopper itself that will expand what you can do. It's so many. It's all available online for free as well. So you can do so much. Oops.
So I can just download someone else's script or maybe that library and use it for my own work in that sense.
Oh, yes.
Yes.
Without a doubt.
I see. It's interesting.
But as you download, you also have to understand how to use that.
Yeah,
Yeah.
right.
Yeah.
Yep.
Mm-hmm.
Definitely. I see. So so let's just say if
Hello.
there is,
Can you repeat that?
sorry, am I lagging?
Yeah. Can you repeat it?
All right, sorry. As I was saying, like let's just say I want to venture into parametric design and I want to be good at it as per se. So how do I be good? Is it through practicing or?
It's definitely through practice.
Yeah. Yeah, because you have to keep learning, and honestly, the best way so far is through practice, and the even better than that is through project-based
Yep.
learning. You know, if you have a project that you really have to do, that kind of like accelerates your learning process so much more. Because that's how we learned it. Me and Jeff learned it in uni because we had to do a project on digital fabrication. We'll share that with you later because that was an intensive workshop, basically. It would run in a very short amount of time, but it allowed us to learn so much in so little time.
And after our university, we also, each one of us has like certain freelance, and that's where we learn even hone our skills even better.
Why it's better to learn with a project in mind is because there's so many components that are available to you. Sometimes you get too lost and you'll be like, what do I use this for? You know, but if you have, like, say you're gonna build a piece of furniture, at least you have a visual of like, I need to create something in this shape, you know, and then from there on you can use the tools to help you to do that. It's always good to start with a project in mind.
I see. So guys, so for today, Ben, Hon, and Jeffrey, they're actually going to demonstrate. They're going to break down they're going to deconstruct a paid project with the tools that they use to create this alien-like structure. So, guys, I'm going to give the floor to you guys, and guys, take it away.
Awesome. Cool. So we'll continue with these slides.
So this is the first project that Jeff is going to show.
So this project was done for Alexander Knox. He's an artist based in Melbourne. So what he has a facade that the architect wanted to design a facade, and he has this kind of art piece that he wants to. It's a building elevation. So he wants to project this image or his art piece onto the building itself. So digitally, it's how do you bring in that kind of image into an actual world of projection in a way that what we did for him is we get this script that we create the system for him that he can easily change his art piece, and it sort of convert his kind of art piece into different kind of patterns that he want to study. Eventually, that kind of information, you can send it to a laser cut machine, and it sort of create a holes or punch hole machine that generally, end of the day, you can create a physical kind of facade for the architect itself. So what we use in this context is we use parametric design to link the digital kind of information into a physical machinery world.
And if you think about it, like traditionally, if someone were to do this, you'd have to resolve changing those designs into little holes that you will plug into metal sheets. And that takes so much work. But with parametric design, you have an image sampler that can take the image, resolve what kind of sizes of the circles you need and where they should be, and generate the instructions for the machinery to cut those holes out right away. So it's a really like from start to end process with parametric design, which is why it's so powerful.
It allows customization in a easier way rather than
Yeah, it's a more efficient way, I would say.
You don't need to draw out the holes yourself. They draw it for you. Yeah, so, and then next one should be fun part.
yeah. We'll use another project to demonstrate how when in Grasshopper world, what it's, because a lot of times when people look at parametric design, they kind of have a different way of idea what it is. This kind of alien-like structure and just visual kind of stuff. Whereas parametric design, there's more than that. What you can do is you can have visualizing, you also can have analyzing, and from what we actually do is this is more of like a digital fabrication context. So when you have, so this is a work done by our mentor Chen. So he has this meeting room that's in RMIT they want to do. I'll show you a picture. What is?
You brought it in, right?
Let you know.
Oh, okay.
So overall, this is the base form is generally you can easily do it in a digital model world, but to get that kind of geometrical patterns and you want to convert into how do you build it, the buildability of it, how to get this information and you transfer to maybe a CNC machine or fabrication machine. So that requires, we use these Grasshopper tools to get that kind of information for us. So we can say like, this is kind of an overall geometry. So this is like a cells, we call it a cells. So it have all different cells compartment and it has this kind of system where you want it to be laser cut, the flat pack system. So what it did was these parametric tools, it exploded in a way that it gives you all these kind of compartments, letting you know which one is it supposed to be in which part. So all this information you can straight send to a laser machine, they laser cut it, and you got all these numbers indicated to tell you which part is connected to which.
Yeah.
So other than using Grasshopper tools to get to link digital stuff into a physical so that you can actually build it, there's also called, what we use is like a geometrical optimization. So we can see this oral form is occasionally, I mean, this kind of project, it teaches you not only a bit of a programming side, also the understanding of how limitation of machinery, also how the way you design to fit into your real world constraint. So some of these examples, like the one highlighted in the pink one, is actually the volume is way too big to fit into a laser machine. So what it did was only some of the components was actually is clustered. So it split up the cells into a smaller compartment. So it helps you differentiate. All this pink one is the volume is more than laser machine, larger than the laser bed. So it differentiates out from there. It further splits the cells into a smaller compartments.
So basically what he's saying is that the script knows the limitation of the machine that you're using, right? So if you have a shape that's too big, it will split it and make sure that that shape can be generated properly, you know? So like you won't have shapes that are too big for your machine. And if there are shapes that are too big for your machines, the script will handle that for you. It will divide it for you and it will generate a cutting sheet for you. So everything is done through the script itself, which is really cool. And like the script itself, like, can you go back to the script? Like it even resolves, aside from just the sizes of the cells and the design itself, and you also go down to like the fixtures as well. So you can see how many screws you need to connect the pieces, what kind of pieces you need to connect, and they actually give you the number of things that you need, which is
the quantity of the screws required to do it and all.
Of course, you have the script in as well, but it's very useful.
It's a very
when
flat
running.
pack kind of a system.
Yeah. So even though the design looks pretty wild, it makes it possible to be done on a laser printing machine, which is generally a flat kind of product, you know. So it's just a 2D cut, but the way that we can resolve the folds, it can create such complex shapes. Yeah.
Sorry, let me interrupt you for a while. Because all these scripts are they free? Do they already is it already
Lagging. Hello.
I think what he said. Can you repeat the question?
sorry, the scripts, are they already with this Grasshopper, or do you have to externally download it?
Everything is, I would say everything is in Grasshopper. We just need to have the knowledge to, you know, which component should we use to do certain or to produce certain kind of design.
So the base Grasshopper plugin itself has many tools that can create this kind of stuff, but there exists many other plugins that can help you do certain things much easier, like help you subdivide surfaces and all that stuff. There's very specific plugins just to help you do that kind of stuff. Although you can do it manually in Grasshopper, but it's less ideal. So it's just like a lot of improvements on Grasshopper itself that are made by people out there and provided for free.
Yep.
So you can start with base Grasshopper, but you definitely want to get in more plugins to help you.
I see. All right, sorry, just carry on, because I was just curious about this script. Like, where do you get the scripts?
Most of it is generally like self-made.
Yep.
Yeah.
So generally, it's always like similar coding, like you have to know what kind of component you requires, that you plug in, that it does certain parts that you need to create this kind of cells, and also it's generally just a simpler way of coding. So like you want to extrude it, you want to split the cells, you want to differentiate it, all this kind of stuff. You have to put in the component to do that kind of outcome that you require. And then occasionally, sometimes we build this kind of script. It might not be a one person kind of thing.
Yeah, it's more of a teamwork thing, because everyone will handle a different part of a component, just like coding. Everyone will have like different part of different role.
Yep.
So in the end, we combine everything together, and hence design comes out.
So what Chen did in this script is he may build the overall script, then people will have his students or other people come in and add in more details into the script itself to create even more hands-on complex kind of outcome that they require.
Yeah.
So now we are going to show you a more, fabricated.
This is the intensive workshop that me and Jeff did while we were at RMIT. And this is just an example of how much you can learn and how much you can make within a short amount of time with proper guidance, I guess. Yeah. So this project, it was to make a partition in the sound studios where we were doing our work. So the client was the university, and there was a design competition technically run, and the winning design was built. So before that, we had an intensive program where we actually had to learn how to use Grasshopper. That was our first time. And so it was run around how many weeks? 6 weeks?
6 weeks. It's a 6 weeks intensive course.
Yeah. 6 weeks intensive course where we learn how to first create base shapes in Grasshopper and how to modify them, and then we got into some design prototyping, and we ended up winning the competition, and we got to build our project. I'll just talk about the project first then. So our project is called Octa because they're like made of some octagonal modules and stuff. So basically they're all made up of these packing geometries. They have really complicated names, so I'll skip that. But we started with physical modeling at first. Oh, sorry, I'm going the wrong way. Yeah, we started with physical modeling at first. And then we realized that we're actually making geometries, right, that are known. So, and then we realized that there are ways that these geometries come together. And if you can see in the middle here, there's this base geometric polygonal model here, which is basically what is behind, what builds up the wall itself. But we broke it down into little surfaces, which you can see here that looks like kind of like bone structures or whatever. So those are our little modules that we created. And then because we were able to use Grasshopper, we were able to create, we were able to plan out a large wall based on this system alone, you know. So, and then we were able to highlight what modules we needed to print. We know how to plan the wall. So this is like the size, the full size of the wall. And those shapes are the wall being filled with just those shapes. So what we did to design the wall is we
Subtract it out.
yeah, we subtracted the volume. Yeah, we subtracted the volume to create like a gateway, you know, and just little interesting nooks for the wall to look like visually. And this is how it looks component wise. It looks very confusing because there's so many of them, and ended up with this kind of wall where you have like an entryway on one side and a wall on the right side. And then we used the Grasshopper to plan the colors as well. That's a very minor use, but you can also use parametric design to design how your product will look, like color-wise, aesthetics as well. And why that is important is because then we know how much, how many of which color we need, you know. And when we know how many modules we need in this certain color, the script will tell us how many sheets of the original material we need to order from the supplier. So that makes it a very efficient way of working, where there's no, well, there's some wastage, but very little wastage, because we know exactly we need, let's say, just 50 sheets of your material. And yeah, so we can have all those numbers ready for us very easily, just because we started with parametric design. And this is how it looks in the space. And this is us doing our prototyping. The material was a felt acoustic panel, so it was very flexible, and we took that to our advantage of how we can connect these pieces together. Yeah, and this is how the wall looks in the end. Staring at the pictures, yeah, you can see they're all built up of those four modules. Was it 4 modules? Yeah, 3 modules, I think. So we have a little video that we can talk through. So that was the digital side of it. And this is basically when it came, so that was 6 weeks of work, the digital side. And we had to produce it. So how long it took was basically 1 day of laser cutting.
It takes a week to produce everything, including laser cutting, building up the walls and all. Within 5 days.
Yeah, it was 2 days. It was just 2 days, not 5 weeks, because we
Yes,
printed
let's give a comparison. If you were to do like your conventional pen and paper, how long would that take instead?
Pen and paper. The thing is, the structure itself is very complex. If you want to do it traditionally, honestly, some of the angles that we had to cut these materials at were very precise, and they were only available to us because we were using, we were designing it in a digital space that was able to generate those specific angles for us, for the octagons to actually connect at the right angles and stay stable and strong. So it's really hard to do it manually. You'd have to do so much of prototyping just to see, like, and it's really hard to see, like, for the first few weeks when we were doing physical projects, we noticed that it wasn't fitting that well But after we actually put it into digital, we realized that it's actually really bad. So after we fixed it, it fit perfectly. So that kind of stuff, we cut the time short very fast. But if you have to do it manually, it'll take you a lot of time and a lot of wastage of material, because you'd have to cut things and you have to put it together, and
you
you
need
see
to
like,
have
oh,
trial and error, you know.
yeah, a lot of power wastage as well, because this is laser printing, and material wastage. We basically skipped all that because we did the testing in digital space.
We basically they had a simulation before that, so
Yeah.
everything works like very much more efficiently. But
Yeah.
if they want to do it manually, I think it would take like, you know, months or maybe
Yeah.
years
Yeah.
just to have those trials and errors.
Yeah.
But they skip all that process and make it a very short time,
Yeah.
because everything were simulated before the fabrication happens.
To add on to your question is, we as a designer, we like to change our design a lot of times. So when you have this kind of settler system, then if you use a manual way of doing it, you have to keep on remodel the digital files all the time, and takes a lot of time. And when you have this kind of gross parametric stuff, it allows us to cut short of the 3D modeling stuff, and we just can focus on our design part and make full use of the efficiency of the tools.
So I'm just gonna play the video in the background, but we're just still gonna talk over it because there's no music or anything. So after we got the pieces laser cutted, we had a bunch of our students or classmates to help clean up the pieces, and then basically that's the process. You can see that in the background we had our test modules. So that was really fun because we had basically a module, right? So it's like a Lego piece in the end. So you can actually build any sort of structure with it as long as you know the weight and you know how much you can take. So you can see in the background, that's way bigger than what we're building, but it's almost like a little dome. So it was a really fun project. And so I think it's over 2 to 3 days, the last bit, where we were laser cutting and we were cleaning up the pieces and we were putting them together and getting ready for the build. And the build and the presentation was on the same day. So this was us in the workshop and just cutting the pieces out of the sheets. Yeah, and yeah.
The reason we have to cut it is because we have such a short time, and certain thing, if you want the laser to cut it perfectly, that requires a longer time frame. So we end up having this kind of final decision where it's kind of a semi-laser cut, then but we manually sort of poke it out of that shape itself.
Yeah. So yeah, so we started building and testing, and
those are flat pack.
Yeah. So these are the pieces that we had to transfer over to the location. There's a little more quality checks.
Yeah.
Okay, so this is the day itself of the build, and it only took how long? A few hours actually, from night till day.
Night to day, yeah.
Yeah, from night till day, half a day basically. So so we developed the system simple enough for anyone to pick up and build it. That's why we have lots of people around. They're not included in our project aside from helping us build it. So it was really nice because the system allowed us to create the module that's very simple for people to understand and build. And that's one of the advantages as well when you're building projects like this, because they come together pretty fast and pretty simply. And once all the modules were built, we could assemble the wall itself. That was like a few hours of just building. And I saw even like the wall itself, how we build it up. I was able to take different layers from the 3D model itself and plan it from layer 1. What modules do we need? Where do we need them right away? So there just needs to be one guy telling you where the one goes, and we started building it up, and the wall went up pretty fast after that. And yeah, this was a very fast project, but I'd say it's a very good learning experience, and it'll be really useful to run this sort of project, but maybe not the physical side, but the digital side for now.
Yeah.
So in the end, we built up the whole wall. See, so we connected them all together. Oh, that's all. So yeah,
Oh, it looks really amazing.
it looks kind of wild, right? Like it's crazy.
Yeah, it's
So,
something that you would never imagine a conventional design.
yeah, but like when you come to the base thinking of the design, it's actually just some shapes and some stacked onto some shapes, but we have extracted the information from those shapes and made it our own, you know. And that's where the creativity comes, I guess, when you're a designer. You make the data work for you, basically.
So where's this project right now? Where is this wall?
This wall is I think it's no longer in RMIT. It used to be in RMIT, but when we moved, when we graduated and everything, I think our mentor took it with him. Yeah. 'Cause I know he keeps one module in his office, but I don't know where the rest are.
Yeah. Part of it is in Swindon now.
Yeah, Swinburne Uni. It's not up anymore though. Yeah, because our mentor left the university when we did as well.
Oh,
Yeah, so
I thought our viewers could go visit this and then be like, oh, this is what parametric design would be.
yeah, that'd be cool. Too bad. But yeah, so that's a example, at least for us, of like what we would like to run in Malaysia itself. Maybe not the physical side yet, because we don't know what's possible yet, but at least the digital side of learning, it would be really nice to spread that kind of knowledge, how to reach this kind of level at least. And I guess
that's the end of our
yeah,
presentation.
that's the end of our demonstration.
Then yeah, I mean for our future planning, like our future venture, maybe you want to talk about it. So I mean, if anyone is interested, anyone can reach out to us, basically. Then after that, we could have some kind of planning, doing maybe some tutorials on like building one small project. For example, we start from small scale, like building like furnitures like that, using parametric and how to configure that. Then after that, hopefully, if everything goes well, we will move to a bigger scale. For example, like what they did in RMIT, like we could do a pavilion in a public space, like for example, outside of like pavilion mall, outside the fountain. Maybe we could build something like that, a public space or an exhibition space. Yeah, that would be really cool for our future endeavors. Yeah.
Really nice.
Anything you guys want to add on?
No, I'm okay. I'm answering the questions in the chat.
Yep.
Lorenzo asked, for a beginner getting into CAD design, would you recommend this more than AutoCAD or Revit or some other CAD design softwares?
Okay, so for CAD designs, there's very specific use to CAD design, so you can't really pick just one software. I normally just use Rhinoceros 3D for all my CAD needs, but the AutoCAD has its place in the industry because they're still using it basically, and Revit has its place as well because that's
Revit's considered as part of a parametric design tools, and it also has its own Grasshopper kind of thing, like it's called Dynamo. Revit side, it's much better to do documentation, whereas Rhino and Grasshopper is much better to do kind of a free-form shape exploration.
Yeah, so basically in a nutshell, it is good to get into this, but you shouldn't ignore the other softwares too. Yeah, that's the hard part about doing what we do. We kind of have to know a lot of everything, a bit of everything, but do specialize though. There's a lot of value in specializing in certain things. Like if you just really want to get into parametric design, get into Grasshopper and specialize into it. The CAD works, CAD designing, that's like, you can easily learn that on the side. This is much more complex. So you can learn that in Rhino, you can learn that in AutoCAD. The skills transfer. I used to use AutoCAD, but I use Rhino now and they're kind of similar. So you don't have to worry where you start, I think. It's more where you end up. Thank you. No problem.
Okay.
Reading the chat. Oh,
Yeah. Later on, we'll drop in Ben, Chan Hon, and Jeffrey's contact. So I mean, if you guys want to keep in touch, go ahead.
Of course.
Yeah, we will put in our Discord link, Discord group
Yeah.
as well. So if you guys need anything,
Wanna
any
have a chat,
questions,
yeah.
want to chat, just feel free to contact us
Yeah.
on Discord.
Yeah. So after learning all this, when people start to get a little bit more interested, or not get a lot more interested, is there a place where anyone can know more about parametric design? So let's just say Lorenzo wants to learn more about Grasshopper. Like, is there a place, a community where Lorenzo
That-
can learn?
Yep, there's a
Yes.
Grasshopper community. This Grasshopper community I've shared last 2 weeks. Basically, it's a community that everyone share their scripts, like upload their scripts. If you got any problem, you have like debugging issues that you don't know how to fix. You upload your script up. Then actually the community is very very active. They will reply you in maybe 2 or 3 days. Then they will explain to you like what went wrong and stuff like that. They will share their views on everything. So yeah, this is the website that everyone goes. So there's a forum. Then you guys can learn everything from here. Like from, of course, beginner, you can learn some tutorials in YouTube. But as you proceed to a more higher level, then you face some problems. This is a community that you need to get on.
Well,
And,
generally,
yeah.
when you're learning this kind of software, it's very important for you to try it out yourself first, because if you, with all communities, like if you ask a question, sometimes they'll ask you back some stuff, and if you don't know how to reply, they can't help you.
Yep.
So YouTube is a really good resource to start with tutorials. Like that's how we mostly learn at YouTube. But these forums are good for troubleshooting. If you run into problems, but you kind of know what you want, they can help you.
Yeah, this is one of the samples
So
that
some people ask a question, and occasionally people help you by sharing them their scripts and explaining to you what went wrong and what could be done better. So it's their Grasshopper community are very helpful to one another.
Yes.
But there's one I would suggest is
what are you searching? Let me do it.
Parametric House. I would suggest is Parametric House. There are few more specific kind of tutorials that you want to do. So they have kind of articles and all. Then there's occasionally they have free tutorials to teach you for certain kind of shapes you want to do. They'll kind of show you videos of how to do it.
This is the very basic forms, I would say.
It will help you understand how Grasshopper works and
the logic behind it.
And what's more important is not the shape when you're learning Grasshopper, is how to get into the mentality of how to design parametrically. Sometimes you have to visualize what you want in the end before you can actually start.
Yeah.
It sounds confusing at first, but it's very different from like, traditional modeling where you start building piece by piece, right? But for parametric design, you have to know that you want a design with these features in it. That's how you can start building that thing. Otherwise, it'll be a bit harder to build, because you don't build them with like little blocks. You build the whole thing at once because they're generated for you.
Like for example, the tutorials here, like you understand the process to get to this shape. But what's important here is like not that final product, it's more of the process. Like what could be done, and if I want to change something, what parameters should I tweak or change to get a different results. The process are more important than the end product, I would say. Yeah.
So there are lots.
If you're a starter and you
you're lagging.
You just lag.
Yeah.
Oh my god. I'm sorry my connection's really bad recently. But yeah, if you're a starter and you want to mention parametric design, so first and foremost, look into Parametric House first. Learn the basics there, and if you are still unsure about what things could be and what things might be, head to the Grasshopper community. What's the website again?
It's just grasshopper3d.com, I guess.
Yeah.
Easier
Yeah,
way
just
is
head to grasshopper3d.com and just ask away.
if you have easier way is normally you have a question, you type it, then you put in Grasshopper at the back. It will generally comes up the forum.
We can easily
Right.
go.
This is just like coding, right?
Yeah, pretty
Yes,
much.
it
yeah.
is. It is coding in a more plug-in
Yeah,
format.
that's
But
right.
yeah, it's just like asking questions, but this time it's for new architects asking questions.
Yeah, that's
Yeah.
right.
That's right. Mhm.
There's a new question right now. TJ Lay,
Oh,
like coming years, and where will you start from?
yeah. Somebody answer that. Influencing the design industry.
Generally, because
Okay, let me answer this question. Is okay, how do we see us influencing the design industry in Malaysia? First of all, we are not trying to, having a revolution or that kind of a thing. So our influence is more on spreading the knowledge on how we could design things efficiently, based on data and parameters, like how to design things minimum wastage, minimum time, do something, give back to the community, I would say. So we will influence in a more educational platform. Like for example, we will take up maybe some projects like public projects. Then after that, we will reach out to the public and to the community, see who's keen on like joining us to do something, like for example, even every product needs a marketing. So basically, that product, for example, Nike, let's say Nike, they want to build something for their exhibition. They could come and contact us. Build this whole thing in a center court. Then from there, after this maybe 2-3 months, in these 3 months, we could search for like anyone that's interested to join us to do up this project. And from there, they will learn the process and they will build these things together.
Yeah.
to add on to what he said is how we gonna influence Malaysia is it depends on the parameter around the country, because occasionally this kind of design may not work in Malaysia, but Malaysia may have a different kind of parameter requires and the shape might be different. But what we can influence is efficiency of getting the outcome or that kind of new design process that we can introduce into a design world or the industry in Malaysia.
Yeah, and then what's important from that as well is as you start using these tools out in the open, and then the contractors or the fabricators start getting used to getting these kind of designs and instructions, a lot more possibilities open up. I think that would be a pretty good influence if possible. Because if I showed you that wall today to a fabricator, they would probably be like, what do you want? Are you serious? Do you really want to make this? But when we come to the base of how we made that, it was just laser cutting flat shapes, So a lot of the current industry people, they don't know what's possible even with current tools. So that's a good influence for us to create, to update the current practices. Basically,
we are trying to broaden the broaden the limitation of like what they can actually do. Instead of like doing boxes and boxes and boxes, this is what they could do. I mean, why aren't you doing it? We are trying to spread that knowledge, to know that there are much more you can do in using current technology, for example.
I see. Then there's one more question coming from Ida Rosdi. Coming from different masters background, how do you think each country you studied in influence how you approach design, and why you want to bring in parametric in Malaysia? I think the second question you answered it already, right?
Yeah, kind of answer it.
Yeah.
I would say.
Yeah. So how do you think each country you studied in influence? So basically, Ben and Jeffrey, you guys studied in Australia, where things are more of a British influence design, I would say, right?
Not really. We were in Melbourne itself, and Melbourne itself is quite a unique place. So It's a very convenient town to do prototyping in. So I would say that lends to why some of the architecture are a bit more wild than others. So there's a lot of creativity in Melbourne. It's a very art positive situation there. There's so much knowledge and art around you, and then you can see that in the creatives who work in Melbourne itself, and that does influence us as well on how we think about things and how we think about making things. We wish when we come back from Malaysia, we always wish like, I wish we could do this here, like certain things. Like we could easily just go to a metal fabricator there and it's like, we want this to happen. Can you help us? Yes, there'll be a straight yes, because they're used to getting these kind of designs. But if we come to someone here with this kind of wild sort of design, we'd probably get a flat no and say that it's impossible, you know. So it influences the design a lot, because the current practice there
culture is different.
Yeah, culture is different. The industry itself knows more things are possible, so we would like that to be changed over here.
That's why our aim at first was mostly in education, because we want to build the mindset and mentality, that the community of the culture in Malaysia first, only then where this kind of project will slowly start to comes out from the academic world.
Yeah, I think that's one of the prime reasons why Jeffrey got into a steel fabrication company.
Because to know all the limitations.
Yeah, he's trying to know all the limitations that what's the current technology, the level of the current technology of Malaysia is at right now, compared to for example, Germany or like Melbourne, Australia. Yeah. So I think our goal are pretty much like we're just trying to broaden the limitation of what we can actually do. Everyone else in overseas are doing it. Why aren't we doing it?
Yeah, that's true. That's right.
Yep.
It's lagging again.
Ben and Jeffrey from
we're back.
Ben and Jeffrey from Melbourne, with this very art positive place, and Chanhan from Germany, one of the best industrial design country in the world, right? So do you guys often frequently have the very conflicting thoughts, I would say?
Since because we know each other in tailors, I think we are quite. What brought us together is because we have the same mindset, same way of working. It's a similar way of working, similar way of thinking, doing projects, and we have been doing projects since in degree together, in group projects. So I think it's not really that hard. Conflict can be solved, of course. I encourage debate and conflicts actually. So it helped us improve, I would say.
Oops. Yeah.
Another question: ever thought of producing similar installation in Malaysia?
Oh yes.
Yes, definitely.
Definitely.
Of course, I've been constantly searching any interested party to do this, but of course we got some offers, but due to some COVID, things are delayed and stuff like that. But if we ever get a project, definitely we'll reach out to the community and see who's interested in joining us. Then we will have this whole learning process and building things up together. Of course, it'll be good for your portfolio.
We're very eager to build things.
Yeah. Alright, so any more questions coming in? Let's give it like a minute or two until then we end the session. Sorry, I don't understand. What's installation? What does it mean?
Installation is more of the. Can we share the slides again?
Actually, that octa wall can consider as an installation itself.
This is an installation, but it's just a functional installation, I would say. It's a very functional installation. This is one of it. And maybe, you know, like what I say, like the projects that if we are eager to get is like, you know, more on like this kind of project is a more public space, you know, maybe an exhibition space. These are installations. It's a contemporary structure.
It's basically
Yeah.
installation itself is just our term of a build, basically.
Right.
I think that's the easiest way to say it. It can be a small build, it can be a big build, but somehow in our industry, we always call them installations.
So the outcome of a model.
Yeah,
Yeah, it's a model. Yes, you're right.
that's right. It gets a bit confusing again. So if there's any
Yeah.
terminology that you need to know, just keep asking.
And normally people use installation as a platform to test out or materiality and their geometrical patterns only. Once if that
Yeah.
works in a much smaller scale, it may work in the larger scale. That's where they
Yeah.
Yes.
And it's a good way to like material innovation, you know, like getting familiar with the material, you know, how this material could expand into a broader usage.
It's basically a good platform for proof of concepts. You know, if we have an idea, we build an installation to prove that you could.
Yeah.
Yeah, that's basically
I
it.
see. And okay, let me ask you. I think there's no one asking more questions. And let me ask you this one final question. Let's just say I'm the client, then I want to put something in a let's just say in the middle of KL. You know, how would you design it? You know, how would you describe the design? Because the thing is, coming from Melbourne, coming from Germany, and now we're in Malaysia. Culturally, the things that we think, the things that we do, everything, it's culturally different, right? So how do you design something? How do you design your installation to fit?
the Malaysian context.
In the Malaysian context, okay.
Yeah, in the
of course,
Malaysian
first of all, I think Malaysian is, you know, lining more to the practical side. Okay, of course, we will start to, you know, understand the brief of the project. Then after that, see what do you need actually, you know, trying to put in functional in a more creative way. And, you know, those are data and the parameters. Then after we get all that, we get the analysis, then we'll come up with the design for you that are suited to your needs. Yeah.
And if you're talking about design aesthetic wise, like, is that what you mean? Like,
Yeah, maybe like, you know, like installation, like maybe your octa wall, you know, how would you convert it into a Malaysian context?
I see.
I think it's more of a material play.
Yeah.
It's a more of a material playing with the materials. For example, their octa are the what you're using again, the sound
acoustic
panel. Maybe in Malaysia we can use like more traditional material like rattan or bamboo to create those kind of things in a very futuristic form. You know, yeah,
that's right. That's
somehow
correct.
tying back to the culture, you know, like Malaysian context.
That's correct.
Alright, it's very interesting. Or maybe you guys could have something with Royal Selangor, you know, those tutors and stuff.
Yes.
I gave you guys a little
endorsement.
So,
let's go.
You gotta put my name inside there already.
Yeah. Cool, everyone.
So anyways, guys,
thank you for
thanks for
inviting us
joining
also,
us.
you know.
Guys, thanks for joining us. It's really interesting. I really learned a lot more about this whole parametric design. I really thought it was just pen and paper, but you know, really, it's more than that. And thank you guys for tuning in with this walkthrough. If you guys love this, please do tag in if you're Discord.
Yes. We will put our Discord link on Facebook, like in the comments, so anyone can feel free to, you know, join the Discord. It's just a friendly, casual community.
It's empty. It's empty right now, but we're planning on building a community, so that's where it starts.
Right, guys. I wish you guys the best. Really, because this is really interesting. It really brings Malaysian architecture to the next level, literally. And yeah, guys, thanks for joining us, and take care. Bye.
Thanks.
Thank you.
Thank you for having us. Bye.